Start that recording. There we go. So yeah, does anybody have any questions that they'd like to go over? Anything from the homework? All right. As planned, we're gonna do our test on Tuesday. All right. We're gonna post a review sheet with the update for today's class. And then you guys can look it over on the weekend. Take it to tutoring, dissect it. It's gonna be, I think, really easy. Probably easier than the first exam. All right. I know that some people sent me an email yesterday. I'm gonna get back to you guys as soon as I can. All right. Fell a little bit behind, but I'm gonna catch up today. Just let you guys know. All right. So other than that, is there any questions that anybody has from the homework? All right. Today's homework is gonna be real easy. It's gonna be an easy day today. All right. Just like um, just like last on Tuesday, excuse me. We only have a couple of questions this week. Nothing challenging. All right. Just solving for X. So I hope you guys take the extra time to study, the extra time that you'll be saving in the class. I'll give you guys 2 minutes in case anybody has their homework open looking for a question. And then we'll begin if nobody has a question. Okay. Well, I'll take it. Nobody has any questions. So let's jump into today's lesson. Today's lesson is kind of simple. We're gonna be doing solving rational equations, right? Solving rational equations. All right. So we have some old fan favorites that we want to just take a quick look at before we jump in. All right. So just want to do a little blast from the past. All right. So I have this equation here, right? I want to solve 1 over 6x plus half, 1/2, excuse me, is equal to a third, right? So how do we do this? What's my first thing that I do? What do you guys remember? What should I first look for? That's the hint. What should I first look for over here? What do we think? What do we think? All right, we should look for the LCD, right? Look for the LCD. Sorry about that. This thing is not cooperating. We should look for the LCD, right? Where's my pens? Oh, I lost my pens. Give me 1 second real quick. I just need to close and reopen this. I apologize. Just give me a second because I lost all my pens real quick. 1 second. Okay. Now we're in business. Sorry about that, everybody. Sorry about that. Let's try this question again. Make that a little bit bigger. Right. So first thing I want to do, right, is I want to find the LCD. Right. And LCD here, we know is going to be 6. Right. So how do I change a 6 into a 6? Right. I'm going to multiply that by 1. Right. But what I do to the bottom, I have to do to the top. Right. How do I change a 2 into 6? I'm going to multiply this by 3, but what I do to the bottom, I do to the top. How do I change a 3 into a 6? I'm going to multiply this by 2, but what I do to the bottom, I do to the top, right? Let's rewrite this equation. And remember, it's an equation, right? So now that I have the same denominator over everything, I can just work with the numerator. So I have 1 times x plus 1 times 3 is equal to 1 times 2. Let's do the math on that. X plus 3 is equal to 2. So I'm going to subtract 3 from over here. What I do to one side, I have to do to the other, right? So now I have x is equal to -1. And that's my answer. And that's it. Is there any questions on this? Any questions? Okay, let's move on. So I have another little blast from the past real quick. All right. So I want to solve this quadratic right here equation. So remember how we do this now? We factor this, right? We factor this. Start off with our parentheses here. Make that equal to 0, right? I'm going to have an n right here and an n right here. And then I need two numbers that when I multiply them will give me 36, excuse me, a -36. And when I add them together will give me a -5. Okay. Now we know that the only way to get a -36 through multiplication is if you have a plus and a minus, right? And we also know that the b term, which is negative in this situation, is negative. So the larger number between the two numbers that I'm going to multiply to give me 36 is going to be negative, right? So let's think about it, right? 36. I want two numbers that multiply to give me to multiply to give me 36, add up to 5, or subtract to 5. That could be another possibility. So let's see. First thing I like to do, I like to start off with my prime factorization tree. Break this up, 36 into 6 times 6. Break that up into 3 times 2. And break this up into 3 times 2. All right? So these are the basic prime numbers that when multiplied will give me 36. And what I'm trying to do is I'm trying to play with them to see what could work here, As soon as I'm looking at the numbers, I'm thinking, let me combine the 3s and the 2s together. So I know 3 times 3 is 9, and I know 2 times 2 is 4, right? So if this was like a -9, for example, -9 times 4 would give me a -36. And if this was a -9 plus 4, that would give me a -5. That's it right there. So -9, +4. After that, remember our zero product property. You're going to set each one equal to 0. So I have n plus 4 is equal to 0, and you have n minus 9 is equal to 0. You're going to solve for n on both sides, right? So I have n1 is equal to -4. I'm going to solve for n on the other side. I'll do to one side, do to the other. So I have n2 is equal to +9. These are my answers to the question. All right, nothing new here. We're just kind of having a little blast from the past. Is there any questions about this? Anybody at all? Any questions? Nope. Okay. So now let's talk about rational equations, all right? That's what we're getting into today, rational equations. This is going to be real quick and real easy. So let me just start off with a definition of a rational equation. So a rational equation, right, is an equation that contains a rational expression. That's simple, all right? It's that simple. And then remember that the difference between an expression and an equation is the equal sign, right? Equations don't have, equations have an equal sign. Expressions don't have an equal sign. So that means that all of my answers that I'm going to get are going to be like this, where I'm solving for a number, right? So I'm going to get I'm going to isolate the variable and I'm going to solve for a particular number, right? Let's talk about it to solve rational equations, right? So we have already solved linear equations that contained fractions. We found the LCD of all fractions in the equation and then multiplied both sides of the equations by the LCD to clear the fractions. We will use the same strategy to solve rational equations, excuse me. We will multiply both sides of the equation by the LCD, then we will have an equation that does not contain rational expressions and thus is much easier for us to solve. But because the original equation may have a variable in the denominator, we must be careful that we don't end up with a solution that would make a denominator equal to 0. So before we begin solving a rational equation, we examine it first to find the values that would make any denominator 0. That way, when we solve a rational equation, we will know if there are any algebraic solutions we must discard. An algebraic solution to a rational equation that would cause any of the rational equations to be undefined is called an extraneous solution to the rational equation. Okay, let's talk about that for a second. Remember when we had the old homework and they asked us for an excluded value? And to find the excluded value, we took the denominator and we set it equal to 0 and then we solved it, right? That's what they're referring to as an extraneous solution to a rational equation. If we took one of those answers that we got from solving the denominator for 0 and plugged it into the equation, right? That solution would be extraneous, right? The answer to the rational equation would be extraneous, right? Because it's illegal to divide by 0. Let's talk about this just a little bit more real quick. Brand new topic, brand new vocabulary. So an extraneous solution to a rational equation is an algebraic solution that will cause any of the expressions in the original equation to be undefined. Any. So do remember that. Let's take a look here. How to solve a rational equation, right? Same way. First thing we're going to do is find what? Find the LCD. Right? In this case, we have an LCD of 6x, right? So I want all the denominators to be 6x. So what do I have to multiply by an x to make it 6x? I'm going to multiply by 6. What would I do to the bottom? I got to do to the top. What do I have to multiply a 3 by to make it 6x, right? I have to multiply this by 2x. What do I do to the bottom? I got to do to the top. And then last but not least, 6, I got to multiply that by x to make it 6x. What do I do to the bottom? I got to do to the top. Now, because it's an equation, I can just work with the numerators and forget whatever came in the denominator on the bottom, right? So this one would be, I'm just rewriting the equations here. Hold on, let me just change up my color. So this would become 1 times 6 is equal to 1 times 2x. Sorry, plus 1 times 6 plus 1 times 2x is equal to 5 times x. All right. Let's do multiplication and all that. This is going to become 6 plus 2x equals 5. After that, we're going to solve for x, right? Subtract 6 from over here. We do the one side, do it to the other. We're going to have 2x is equal to negative 1 divided by 2 divided by 2. X is equal to negative 1 over 2. Questions on this? Anybody? When doing this, you should also verify that by the answer that you found is not going to make any denominator equal to 0. In this case, our denominator is just plain old x. So if I plug in negative 1, it won't be 0. Questions on this? All right, if there's no questions, then let me give you guys one to try. All right, go ahead. All right, let's take a look. So over here, right? First thing we want to do, find that LCD. Over here, I'm going to have LCD what? 5 times 3 times y, call that 15y, right? So I want to change that y into a 15y, so I'm going to multiply this by 15. What I do to the bottom, I do to the top. I want to change that 3 into a 15y, right? So what am I going to do? I'm going to multiply this by 5y. What I do to the bottom, what I do to the top. I want to change that 5 into a 15y, so I'm going to multiply this by 3y. What I do to the bottom, what I do to the top. Let's rewrite this and see what we have. Because it's an equation, I don't need the denominator no more. So I have 1 times 15 plus 2 times 5y is equal to 1 times 3y. Very simple. Let's do the math on this. 1 times 15 is just 15. Plus 2 times 5, 10y, is equal to 1 times 3y, 3y. After this, we're going to solve for y. So I'm going to subtract 10y from over here. Where I do to one side, I do to the other. Now I have 15 is equal to a negative 7y. Then you're going to divide by negative 7, which you do to one side, you do to the other. So now what do I have? I have y is equal to negative 15 over 7. And that's it. All right. One thing you can also do, since we have the LCD, you can verify, since we know the LCD is equal to 15y, you can verify that the denominator, right, will not go to 0 by the answer that you found by plugging it into the LCD. So if we found the LCD of negative 15 over 7, right, that would be 15 times negative 15 over 7. You don't even have to answer this. All I want to know is that answer that you just gave, that you just found, right? The 15 times negative 15 over 7. Is that equal to 0? That's all I want to know, right? If the answer is no, then you're good to go, right? Then you're good to go. You know that this will not make the denominator 0, so everything will work out. If it does, then we have an extraneous solution. And that's it. Yeah. Real quick, let me just go give you guys some notes. I know some people like to take notes, so this is for you. This next part. So how to solve equations with rational expressions. Step 1, note any value of the variable that will make any denominator 0. Step 2, find the least common denominator of all the denominators in the equation. Step 3, clear the fractions by multiplying both sides of the equation by the LCD. Step 4, solve the resulting equation. Step 5, check. If any values found in step 1 are algebraic solutions, discard them. Check any remaining solutions in the original equation. Okay. So we want to solve this rational equation over here. I'm going to rewrite this as 1 over 1 minus 5 over y is equal to negative 6 over y squared. Next, I want to find the LCD. We can see that our LCD is going to be y squared. So I want every single denominator to have y squared. So I'm going to change this 1 into a y squared. So I'm going to multiply this by y squared. But what I do to the bottom, I got to do to the top. I want to change this y into y squared. So I'm going to multiply this by y. But what I do to the bottom, I do to the top. I want to change the y squared into a y squared. So I'm going to multiply this by 1. But what I do to the bottom, I do to the top. That being said, because it is an equation, right, I'm just going to use the numerators. That's it, right? So this is going to become 1 times y squared minus 5 times y is equal to 6 times 1. Let's do the math on this. Y squared minus 5y is equal to 6, right? And then we just want to solve for y. So I'm going to subtract 6 from over here. Where I do the one side, do to the other. So now I have y squared minus 5y minus 6 is equal to 0. And we want to solve this by factoring, right? Two numbers that multiply to a negative 6 and add up to a negative 5. So I'm thinking about x minus 6, x plus 1. Equals 0. Let's set both of these equal to 0. Right? And I want to solve for each one. So I'm going to add 6 from over here, where I do the one side, do to the other. And then I'm going to subtract 1 from over here, where I do the one side, do to the other. Now I found two answers. Remember what we want to do. We want to verify that they're not going to make the denominator equal to 0, right? So we found LCD to be y squared, right? So if the LCD is equal to y squared, then the LCD of 6, for example, is equal to 6 squared. And 0 does not equal 6 squared. The LCD of -1 is equal to -1 squared, right? And the LCD of -1 squared does not equal 0. That's it. So both answers are correct. Any questions on this, please? Anybody?
Yeah, I got a question.
Go ahead, ask.
How do you tell? Or is there like a way, or is it just because their symbols are different?
How do I tell which one? Sorry.
Like that they won't interfere.
Oh, I'm just plugging them in the LCD. That's how I'm telling.
Okay. So you just basically resolve.
Yeah. I mean,
Okay.
if you want, you could plug it into the original and then go about it that way as well. Yeah,
All
just
right.
have options. Yeah, I feel like the LCD one is the easier one though. Yeah. Oops. I'm gonna let you guys try one. So yeah, go ahead, try that. All right, let's take a look. First things first, I want to find the LCD over here. And we could tell that the LCD over here is going to be what? X squared, right? So let me rewrite this. I have 1 over 1 minus 2 over x is equal to 15 over x squared. And remember that 1 is a whole number, so I'm allowed to put it over 1, right? Because it's a whole number. All right, LCD over here, we know is x squared. I want to make the 1 and 2 an x squared, so I'm going to multiply that by x squared, right? But what I do to the bottom, I got to do to the top. I want to change this x into an x squared, so I'm going to multiply this by x, but what I do to the bottom, I got to do to the top. I want to change the x squared into an x squared, so I'm going to multiply this by 1, so what I do to the bottom, I do to the top. Let's rewrite this now, and because it is an equation with an equal sign, right, I don't need the denominator no more. So I have 1 times x squared minus 2 times x is equal to 15 times 1, right? Let's do the math on that. So I have x squared minus 2x is equal to 15, right? No problem here. Let's simply just plug in our, let's just solve for x, that's what I meant to say, right? So I'm going to subtract 15 from over here. What I do to one side, I must do to the other. So now I have x squared minus 2x minus 15 is equal to 0, right? After that, I want to factor this. If I'm factoring this, this is going to become what? X right here, x right here. I want two numbers that multiply to a negative 15. So now I'm going to have a plus and a minus. And they have to add up or subtract to a negative 2. 15, I'm thinking, 3 and 5, right? 5 being bigger, so 5 and 3 right here. That looks about good. And then you already know, set both of these equal to 0. So x plus 3 equals 0, x minus 5 equals 0. I'm going to subtract 3 from over here, where I do to one side, do to the other. So I have x1 is equal to negative 3. I'm going to add 5 over here, where I do to one side, do to the other. So I have x2 is equal to 5. These are our two answers, but we need to verify if they work, right? So we know that our LCD was x squared, right? So what I want to know is, what is the LCD of negative 3, for example, right? That's going to be equal to negative 3 squared. And what I want to know is 0 equal to negative 3 squared? And indeed, we find out that it's not, right? So we're good. Negative 3 is an answer, right? Let's find the LCD of 5, right? So I know that that's going to be what? 5 to the second power. So what I want to know is 0 equal to 5 to the second power? And indeed, we know it's not, right? So 5 is also an answer. And that's it. That's how we solve our equations. Any questions? Anybody? All right, if there's no questions, let's move on. All right. I'm going to do another example real quick. Same idea as what we've been doing today. It's just gonna look a little bit different. All right, so I have 2 over x plus 2 plus 4 over x minus 2 is equal to x minus 1 over x squared minus 4. First thing I want to do, I'm going to rewrite this and factor it at the same time. So I have 2 over x plus 2 plus 4 over x minus 2. You know, I'm going to write these in parentheses just to make it look pretty, is equal to x minus 1, parentheses, over, I'm going to factor the x squared minus 4. We know that's the difference of two perfect squares, so x plus 2 and x minus 2. Now I want to find the LCD over here, my LCD, you could tell, is just the x plus 2 times the x minus 2. That's my LCD, right? So now I want to make the x plus 2 into an x plus 2 times x minus 2. So I'm going to multiply this by x minus 2. What I do to the bottom, I got to do to the top, x minus 2. I want to change my x minus 2 into an x plus 2 times x minus 2. So I have to multiply this by x plus 2. What I do to the bottom, I do to the top. Last but not least, I have the x plus 2 and the x minus 2 there. So I'm going to multiply this by 1. What I do to the bottom, I do to the top. Let's rewrite what I have here now without the denominator because it's an equation. I have 2 times x minus 2 plus 4 times x plus 2 is equal to 1 times x minus 1. Let's do the math on this. Distribute, 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 and distribute, distribute. So I get what? 2x minus 4 plus 4x plus 4, excuse me, 8, excuse me, 8, sorry about that, is equal to x minus 1, right? Let's combine like terms now, right? So 2x plus 4x is 6x. Negative 4 plus 8 is positive 4, which is equal to x minus 1. And very simply, I just want to solve for x. I just want to solve for x. So I'm going to subtract x from over here. What I do to one side, I do to the other. Now I have 5x. I'm going to subtract 4 from over here. What I do to one side, I do to the other. So now I have equals negative 5. Divide by 5, divide by 5. So x is equal to negative 1. Right? But I can't just take it at that. I have to check it out.
Wouldn't it still be 8?
I'm sorry.
Oh wait, never mind. It's
8.
X instead.
I'm sorry. Did I call it X and there was an A in the question? I'm sorry.
No, it was my fault. I looked at it and I thought it was 2 4s instead of just one.
Got you. Got you. Okay. I thought I made a mistake there. All right. So look, we definitely want to check this in our LCD again, right? So I know that my LCD, right, is what? X plus 2, x minus 2, right? What I want to know is what is the LCD of negative 1? Well, we know that that's going to be what? Negative 1 plus 2, right? Times negative 1 minus 2. And my question is, right? Is the negative 1 plus 2 times the negative 1 minus 2, is that equal to 0? And indeed, it's not. So therefore, x minus 1 is an answer to this question. And that's it. There's no extraneous solutions. Well, there are extraneous solutions. There will be 2 and negative 2, but negative 1 is not an extraneous solution. Let me say it like that. Any questions on this from anybody? Questions from anybody? All right. Seems like we're understanding very well today. I'm gonna let you guys try one. Right, try that out, everybody. All right, let's check this out. I'm gonna rewrite this. I have 2 over x plus 1. Put this in parentheses. Plus 1 over x minus 1 is equal to 1 over, I'm going to factor this, x plus 1, x minus 1, right? Difference of 2 perfect squares. Now I want to look for my LCD. I know that my LCD is going to be what? X plus 1 times x minus 1. All right, let's write these in. So for the first denominator, I have x plus 1. I want to change that into x plus 1 times x minus 1. So I'm going to multiply this by x minus 1. What I do to the bottom, I do to the top. I have an x minus 1 in the second fraction. I'm going to multiply this by x plus 1. What I do to the bottom, I do to the top. I have an x plus 1 times x minus 1. So I'm going to, and I want to change that into an x plus 1 times x minus 1. So I'm going to multiply this by 1. What I do to the bottom, I do to the top. Now let's rewrite this, right? Without the denominator because this is an equation. So I have 2 times x minus 1 plus 1 times x plus 1 is equal to 1 times 1. Let's do the math on that. I'm going to distribute this. I'm going to distribute that. I'm going to distribute that. So now let's look at what we have. I have 2x minus 2 plus x plus 1 is equal to 1. Let's combine like terms. So that's going to give me 3x minus 1 is equal to 1. I'm going to add 1 over here. What I do to one side, I do to the other. So now what do I have? I have 3x is equal to 2. I'm going to divide by 3. What I do to one side, I do to the other, right? So I have x is equal to 2 over 3. But the question is, though, right, is that a valid solution? Now, we know that my LCD is x plus 1, x minus 1, right? What I want to know is what is my LCD of 2 over 3, right? So what I want to know is 2 over 3 plus 1 times 2 over 3 minus 1, right? Is that equal to 0, right? Does this equal 0? And the answer is no, it doesn't, right? So this x equals 2 over 3 is a valid solution. Any questions? Any questions at all? Nope. All right, let's move on. Not a problem. I get it. This section is probably really easy for you guys. No problem. Let's take a look at this question. Same kind of idea. I have m plus 11 over m squared minus 5m plus 4 is equal to 5 over m minus 4 minus 3 over m minus 1. Very simply, I'm going to rewrite this. But what I want to do, I want to factor them as I'm rewriting it. So I have m plus 11, excuse me, over m minus 4, m minus 1, which is equal to 5 over m minus 4 minus 3 over m minus 1. All right, let's find the LCD. LCD is going to be m minus 4, m plus 1. M minus 4, m minus 1. Now, I want to make these all have the same denominator. So the first term has m minus 4, m minus 1. I'm going to multiply that by 1 because it has what I'm looking for. What I do to the bottom, I do to the top. I have the m minus 4 in the second term, but I'm missing the m minus 1. What I do to the bottom, I do to the top. Oops. Last but not least, I have m minus 1. I want to multiply this by m plus 1. Excuse me, m minus 4. Sorry about that. What I do to the bottom, you gotta do to the top. I'm gonna rewrite this time without the parentheses. So I have m plus 11. None of this is equal to 5 times m minus 1 minus 3m minus 4. Right? Distribute this. I have m plus 11 is equal to 5m plus 5 minus 3m plus 12 equals 0. Let's combine like terms. I have m plus 11 is equal to 2m plus 17. After this, I want to subtract m. 11 is equal to m plus 17. I'm going to subtract 17 from over here. So now what do I have? M is equal to negative 17 over 11. Wait, sorry about that. This is negative 6. M is equal to negative 6. There we go. Wait. 4. Oof. One of those days. Happy Halloween. Spooky things that happen. Spooky things that happen. So m is equal to negative 4. Now, according to my LCD, which is x minus 4, x minus 1, what is the LCD of negative 4? That is negative 4 minus 4 and negative 4 minus 1. Does that equals 0? And in fact, it does not. So m negative 4 is an actual answer. Questions on this? Any questions? No questions? Okay. You guys try. Try that out. Try that out. All right, all right. Sorry about that. Let's get back at it. So I want to rewrite this, but I want to factor this as I'm going. Right. So I have x plus 13. And the fact this is on the bottom, so this is going to be what? X, I think, minus 5 and x minus 2. I need two numbers that multiply to give me 10. I'm going to add them together to give me a -7. That looks good. Then I'm going to have a 6 times x minus 5 minus a 4 time over x minus 2. Right? And then what do we want to do after that? Right? I want to find that LCD. LCD over here we know is x minus 5 times x minus 2. So over here in the first term, I already have all of that. So I'm going to multiply this by 1. What I do to the bottom, I do to the top. X minus 5, I need that to get an x minus 2. What I do to the bottom, I do to the top. Last but not least, right, we have the expression that has x minus 2. I'm going to multiply that by the x minus 5 to make it the LCD. What I do to the bottom, I do to the top. Now, because this is an equation, right, I'm going to rewrite this without the denominators now. So I have x plus 13 times 1 is equal to 6 times x minus 2 minus 4 times x minus 5, just like that, right? After that, let's do some math on this. I'm going to distribute. Let's see what I get. 1 times x, 1 times 13 plus 13 is equal to 6 times x, 6x, 6 times -2 minus 12, -4 times x, -4x, -4 times -5 is going to be positive 20. After that, let's combine like terms. I have x plus 13 is equal to 6x minus 4x is going to give me a 2x. And then -12 plus 20 is just going to give me a positive 8. After that, I want to solve for x, so I'm going to subtract x from over here. What I do to one side, I do to the other. I'm going to subtract 8 from over here. What I do to one side, I do to the other. So now what do I have? I have 5 is equal to x. And that's my answer. But I can't just go with that. I can't just go with that. I got to verify, right? Verify that this actually works with my LCD. So when I take out my LCD, right? Remember our LCD is what? X minus 2 times x minus 5. And what I want to know is if I plug this into the LCD, right? Does that equal 0? So let's check it out. Let's check it out, right? What I want to know is 5 minus 2 times 5 minus 5, does that equal 0? And in fact, it does equal 0, right? So because of that, this is not a solution, right? So this is a question that has an extraneous solution for an answer. So the answer to this is no solution, right? So just so you know, these things can happen, right? If this was web work, I think you can get away with just saying n/a or like no solution. The instructions in the question will tell you what to type in if you encounter a question where there is no solution. All right. So always remember to check your answers. Check your answers. Check your answers. All right, let's look at another one. So I have y over y plus 6 is equal to 72 over y squared minus 36 plus 4. Now you remember, because 4 is a whole number, I can write that over 1 as so. So let me rewrite this, please. This is going to become y over the y plus 6 is equal to 72 over, I'm going to factor this now. This is going to be y minus 6, y plus 6. Plus the 4, which is over 1, right? Now, I want to find my LCD. All right, let me just kind of pull this up just a little bit. Oh, Lord. Listen to me. One sec. Oh, there we go. So I just want to find my LCD real quick. Now we could tell that my LCD is going to be what? The y minus 6, y plus 6. Very good. So now, right, what do I want to do? I want to get the same denominator over everybody. So I have the y plus 6 over here. I'm going to multiply this by y minus 6. What I do to the bottom, I got to do to the top. Over here, I have y minus 6, y plus 6. So I'm going to multiply this by 1. But what I do to the bottom, I got to do to the top. For the 1, right, I just have 1. I need to multiply this by y minus 6 and y plus 6. What I do to the bottom, I got to do to the top. And that's it, right? I'm going to rewrite this now because everybody has the same denominator without it. So I have y times y minus 6 is equal to 72 times 1 plus 4 times y minus 6, y plus 6. All right. After this, let's do some multiplication, combine like terms, all that fun stuff, right? So this is going to become y times y, right? And y times negative 6, it's going to be y squared minus 6y is equal to, this is just going to be 72. And over here, I'm gonna distribute that 4 in a second. First, I want to FOIL this, right? So we're gonna come out with y squared minus 36, difference of two perfect squares. Now let's distribute that 4. So now what do I have? I have y squared minus 6y is equal to 72 plus 4y squared minus, I'm not even gonna lie, I don't know what that is. What is 36 times 4? 144. Not so bad, not so bad. Okay, let's combine like terms now, right? So I'm going to subtract y squared from over here. Where I do to one side, I do to the other. I'm also going to add 6y over here. Actually, wait, no, I shouldn't even do that. Hold on. Let's finish doing this. So this is going to be negative 6y is equal to 72 plus 3y squared minus 144. Now, I made a mistake. I should have combined like terms first. It's okay. We're going to do that now, right? When I combine like terms, I have negative 6y is equal to 3y squared minus 72. I'm just adding the 72 plus the negative 144. Boom, right? So then now I'm going to add 6y over here. Where I do to one side, I do to the other. Now notice 6y is not a like term for these other two terms, so it's just going to go in the middle of it. So 0 is equal to 3y squared plus 6y minus 72. All right, let's factor out a 3. All right, greatest common factor. Remember, we always look at that first, right? So this is going to be y squared plus 2y minus, what's that, 72? That's going to be our 24 right there. That's not so bad at all. Not so bad at all. All right, so I have 0 is equals to 3 times. Let's factor this out. I'm thinking about 6 and 4. About y plus 6 and a y minus 4, right? 6 times 4, 24. 6 plus negative 4 is positive 2. Not so bad. I'm going to set both of these equal to 0. Y plus 6 is equal to 0. Y minus 4 is equal to 0. And then just solve for y. Subtract 6 from over here, where we do the one side, do to the other. So I have y1 is equal to negative 6. Add 4 over here, where we do the one side, do to the other. So y2 is equal to 4. And that's it. Right? But you know I can't leave it like that, right? Can't be done. It can't be so easy. I have to verify that this will actually work with my LCD. Let's verify that. Just a recap, my LCD is y minus 6, y plus 6, right? Let's check it out. So that is y minus 6, y plus 6. So what I want to know, if I did the LCD of, let's say, negative 6, right? For negative 6 minus 6 times negative 6 plus 6, does that equal, hold up, ran out of space. Does that equal 0? Right? And in fact, it does. 0 equals 0. Right? So this is not an answer, right? What about my LCD of 4? Let's verify that, right? So this is going to be what? 4 minus 6 times 4 plus 6, right? Does that equal 0, right? And we see that it does not equal 0, right? Because this is like what? Negative 2 times 10, right? Right? It does not equal 0. So therefore, right, this is my final answer. The y equals 4. And that's it. Any questions on this? So it's a different kind of question. But it's the same thing that we've been doing all day, right? Solving the rational equation. Any question on this? Anybody? All right, I'm going to let you guys try one. Try this out. All right, let's take a look. I'm going to rewrite this and factor it at the same time. So I have x over x plus 4 is equal to 32 over, I'm going to factor this, x minus 4, x plus 4. And that's plus 5 over 1, right? Now, what do I want to do? I want to find the LCD. So we know that my LCD over here is going to be what? X minus 4, x plus 4. Just like that, right? So I want to make sure that I have the same denominator under everybody. So I'm going to start off with the first term, x over x plus 4, right? I want to multiply this by x minus 4 to make it have the LCD, but what I do to the bottom, I must do to the top. Over here, I have the x minus 4 and the x plus 4 already on the bottom, so I'm going to multiply this by 1, but what I do to the bottom, I do to the top. Last but not least, I have a 1 by itself, so I'm going to multiply this by x minus 4, x plus 4. What I do to the bottom, I gotta do to the top. Now, what I want to do is I want to rewrite this, right, without the denominator. So I have x times x minus 4 is equal to 32 times 1 plus 5 times x minus 4, x plus 4. All right, let's go ahead and let's do that math out, right? Distribute, 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 and then distribute, distribute, all that good stuff, right? So I'm going to have x squared minus 4x is equal to 32 plus 5 times x squared minus 16, right? Hold up, okay. Now let's distribute this. So I have x squared minus 4x equals 32 plus 5x squared minus, let's take a look, 16 times 5, 80. Not so bad, right? So I'm going to subtract x squared from over here where I do the one side. You know what? I did that same mistake again. Let's not repeat that mistake. Combine like terms. This becomes x squared minus 4x is equal to, right? Let's see. We have negative 80 plus 32. It's going to give me a negative 48. So this is 5x squared minus 48, right? Not so bad. Let's move everything to one side so that we can factor this. So I have minus x squared here. I do the one side, do to the other. I'm going to add 4x over here. Where I do the one side, do to the other. So I have 0 is equal to 4x squared plus 4x minus 48. Greatest common factor here looks to be 4, right? So let's factor that out. Leaving back 0 is equal to x squared plus x minus 12. Let's try that again. Ooh. 0 is equal to 4 times x squared plus x minus 12. Okay, that looks good. All right, let's factor that out now. 0 is equal to 4. This is going to be a positive and negative situation. All right. And then two numbers that multiply to negative 12 and add up to x. I'm thinking about positive 4, negative 3. Yep, that seems about right. Now let's set both of these equal to 0. X plus 4 equals 0. X minus 3 equals 0. Solve for x, subtract 4, subtract 4. X is equal to negative 4. Add 3, add 3. X is equal to 3. All right. But you know I'm not done. I have to verify that. But let's verify this. Look for my LCD, right? So my LCD is x minus 4 times x plus 4. All right. Now, if I look for my LCD of -4, that means -4 minus 4 times -4 plus 4, right? What I want to know is, does that equal 0, right? And in fact, it does. 0 equals 0, all right? So this is not an answer. Let's try it out for 3. I want my LCD of 3, right? So that means that I have 3 minus 4 times 3 plus 4. What I want to know is, does that equal 0? And in fact, it doesn't, right? Because -1 times 7 does not equal 0. So x equals 3 is my final answer. Questions on this? Anyone? All right, let's keep it moving then. There's no questions. By now, you should probably get the gist of it. This is just the same thing again and again and again. That's all it is. Let's look at this example now. So I have y over 5y minus 10 minus 5 over 3y plus 6 is equal to 2y squared minus 19y plus 54 over 15y squared minus 60. So what I want to do here, I want to factor this, right? I'm going to rewrite it and I want to factor it at the same time. So let's do that. So I'm going to have y over 5 times x minus 2 minus 5 over 3 times, why did I say x? I'm sorry, y minus 2. Factor out a 3 and I have y plus 2. Okay, let's keep it going. I'm going to factor out the top. This is going to be 2y times y over here. This is going to be a negative situation. I want two numbers that multiply to give me 54, add up to 19. Let's see. If I break up 54, half of this would be what? 25, 26, 27. And 2. Break this up, that's 9 and 3. This is 3 and 3, so I have 3, 3, 3, 2. What can I do with that? Let's see, 6 and 9. No. Just trying different combinations in my head, right? How we could do this. 27 and 2, nope. That's not good. 6 and 9, call that 12. And that's going to be too big. Let's see, 6 and 3, no. It's a good question, this one. Got to think about this. 15 out here. This is y squared minus 4. Times 2, that would be 4. No, that's not it. Hmm. 18 and 6, no. Three times 2 is 6. This one got me. This one got me. Might have to do the AC method on this. Before I give up and say that we can't factor it, let's try the AC method. So A times C we know is 2 times 54. $108. B term is negative 19, right? Two numbers that multiply to give me 108 and add up to a negative 19. This is going to be a negative negative situation again, right? So 108, 54, 2. This would be like 2, 27, 9 and 3, 3 and 3. Okay. So now negative 19. Da, 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 da. 27 and 4 doesn't do it. 18 and 6, no. 54 and 2, no. 18, 9, no. This one got me. I guess we can't factor this. Which is okay. Sometimes that happens. Let's kick that back to the original. 2y squared minus 19y plus 54. Okay. Let's factor this one more time. So I have y over 5 times y minus 2 minus 5 over 3 times y plus 2 equals 2y squared minus 19y plus 54 over 15 times y minus 2 times y plus 2. Awesome. All right, LCD. LCD for us is going to be 15 times y minus 2 times y plus 2. All right. Now we want to make everyone have that LCD. In the first term, I'm missing a 3 times y plus 2 to get that LCD. So what I do to the bottom, I got to do to the top. So 3 times y plus 2. Next, I'm missing a 5 and a y minus 2. So what I do to the bottom, do to the top. So 5 y minus 2. Last but not least, that's a 1, 1, boom. So let's rewrite this. Let me, just for completion, do it like that, right? Let's rewrite this without the denominator because now we're good. I'm going to say 3y times y plus 2 minus, I'm going to say 25 y minus 2 is equal to 2y squared minus 19y plus 54. Okay. Let's distribute this. All right. Then we're going to combine like terms. This becomes 3y squared plus 6y minus 25y. Negative is positive 50 is equal to 2y squared minus 19y plus 54. Right? Combine like terms, 3y squared minus 19y plus 50. I don't know what just happened there. Minus 19y plus 50 is equal to 2y squared minus 19y plus 54. Right? Not too bad. Put all my on everything on one side. So I'm going to subtract 2y squared from over here. Where I do the one side, do to the other. I'm going to add 19y over here. Where I do the one side, do to the other. And then I'm going to subtract 54 from over here. Where I do the one side, do to the other. So now what do I have? I have y squared minus 4 is equal to 0. You already know y plus 2, y minus 2 is equal to 0, right? And then we're just going to finish solving this. No problem. No problem, Franklin.
So, like, you think it was different or what?
Delete this real quick.
I was like, I was laughing, bro.
Hang on a second. All right, we good to go. So now individually, I want to set both of these equal to 0. 1 second. Set both of these equal to 0. Y plus 2 and the y minus 2 equal to 0. I'm going to subtract 2 from over here. So I have y1 is equal to negative 2. I'm going to add 2 over here. So I'm going to have y2 is equal to 2. Okay. Found 2 answers, but I got to verify them. Let's get that LCD out, all right? So for me, LCD was 15 y minus 2 y plus 2. $15 y minus 2 y plus 2, right? And when I do the LCD of negative 2, that means what? Negative 2 minus 2 and negative 2 plus 2. Does that equal 0? In fact, it does. 0 equals 0. That's not a solution. What about the LCD of 2? Let's check that out, right? That means what? That means 2 minus 2 times 2 plus 2. Does that equal 0? And in fact, it does. 0 equals 0. So for this question, no solution. Any questions on this one? Anybody? All right. There's no questions. I'm going to move on. I want to give you guys a little bit of time back. So I'll do one more example. And then you guys should be pretty much prepared to knock out your homework after this example because you've seen everything. Here's the question. I have 4 over 3x squared minus 10x plus 3 plus 3 over 3x squared plus 2x minus 1 equals 2 over x squared minus 2x minus 3. So what's different about this question is that I have to factor each and every single denominator here before I find my LCD. So let's do it, right? So I'm going to have 4 over, this one's going to be 3x Let's figure this out. And this is going to be x. I need two numbers that multiply to give me 3. That's 3 and 1. And I know that they have to add up to a -10. So this is a negative, right? So I'm thinking about 3 times 3 is 9. And I'm thinking about 1 right here. Okay. Plus I have 3 over here. Then this is going to be same thing, a 3x here and an x right here. I need two numbers that multiply to give me 1. We already know that's 1 and 1, right? And this is going to be a positive situation. So this is going to be positive here, negative here, right? That looks good. And then this is going to be equal to 2 over, I'm going to factor this. This is x and x. This is going to be a -3. So it's going to be a positive and negative situation. So positive here, negative here. And then I want -3, +1, boom. Everything is factored. Next, let's find the LCD. All right. So looking at my factors, I would say LCD is 3x minus 1 times x minus 3 times x plus 1. Just kind of put everything together, so to speak, right? Now, first term with the 4 over the 3x minus 1 times x minus 3. I'm missing an x plus 1, excuse me. What I do to the bottom, I must do to the top. For the 3 over the 3x minus 1 and the x plus 1, I'm missing an x minus 3. What I do to the bottom, I do to the top. Last but not least, I have x plus 1, x minus 1, right? Excuse me, x plus 1, x minus 3, I'm sorry. This is missing and 3x minus 1. What do you do to the bottom? You do to the top. And that's it. Let's rewrite this time without the denominators because we have an equation, right? So 4 times x plus 1 plus 3 times x minus 1, right, equals 2 times 3x minus 1. Distribute, 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 distribute. And then let's combine like terms and all that good stuff. This becomes 4x plus 4 plus 3x minus 3 equals 6x minus 2. Combining like terms, I'm going to have 7x plus 1 is equal to 6x minus 2. Then I want to subtract 6x from over here. Where I do to one side, do it to the other. So x plus 1 is equal to -2. I'm going to subtract 1. X is equal to -3. Now, judging by my LCD, if I look for the LCD of -3, am I going to find -3 up in here? So this is going to be 3 times -3 minus 1. -3 minus 3. -3 plus 1. My question is, does that equal 0? And in fact, this is like what, -9, let's call that -10 times -6 times -2. Does that equal 0? And in fact, it does not, right? So therefore, x minus 3 is a correct answer. And that's it. Any questions on this so far? Anybody? All right, well, that's the topic for today. So I'm going to give you guys a couple minutes back from class. Please use the time wisely. All right, we're going to have our test next week on Tuesday. I'm going to post a formula sheet. The post is not going to come right after class. It's going to give me a couple minutes, because we need the recording to download and all that the other stuff, right? But you will have the post by tonight. All right, you have my word. You'll have the post by tonight. In the meantime, do your homework. Catch up on your homework. Everything up to this day will be on the test. All right. You'll see the review sheet more specifically what topics will be on the test, and everything will be good.
I'm sorry, when's the test again?
Tuesday. November 5th. Tuesday, November 5th. Election day, right? Come in, take the test, go vote. Right? Good times, good times. Happy Halloween, everybody. All right. I hope everybody has a great night tonight. All right, I'm giving you guys a little bit extra time back. Once again, tutoring is open today until 8 p.m. Tutoring will be open Friday and Saturday from 12 p.m. to 6 p.m. Make an attempt to come, right? Pantry next week. All right. And that's it. All right. So I'm going to run you guys. Have a blessed one. I'll see you guys next week. All right. If you guys need anything, email me. Those of you that did email me, catching up right now. I'm going to respond back as soon as I get to it. All right. Have a good night. Talk to you soon.